Descent to the metal, bridging mind and machine. Have you ever actually stopped to think about what happens the exact millisecond you hit enter on a command? Like, how does a fuzzy, abstract idea bouncing around in your head actually turn into a physical action in the real world? Well, in this explainer, we're going to trace the path of a single human thought literally all the way down to the bare metal. Let's dive in.
So how do we get cold, unthinking silicon to understand our highly associative human thoughts? I mean, we're dealing with a staggering conceptual gap here, right? We're trying to bridge two completely alien universes. On one side, you have us, human beings, and on the other, a microchip. How in the world do we get a cold, unthinking piece of metal to process our emotional, free-flowing thoughts without just completely mistranslating the whole thing?
To really grasp this, just look at the stark contrast between these two systems. Over on the left side, you've got human cognition, which we affectionately call OS alpha. OS alpha is warm, it's fluid, highly associative, and, let's be honest, wonderfully messy. We think in feelings, we think in context, but on the right side, deep down inside your computer, sits the arithmetic logic unit, or the ALU. This physical silicon hardware is ice cold, it's rigid, and it's strictly deterministic. There is absolutely zero meaning down there. 1 + 1 = exactly 2 every single time. So the big question is, how do we cross this massive philosophical chasm?
Well, the crucial point here is that we cross it using what our sources call the semiotic bridge. To put it simply, text, specifically strictly formatted texts like JSON or Python code, acts as this structural bridge. You can kind of think of it as a divine script. It's this exact, universal, deterministic interface that takes your messy, nonlinear human imagination, completely strips away all of the fuzzy ambiguity, and compiles it into the rigid, absolute instructions that the silicon processor absolutely requires. It forces the machine to execute exactly what you designed, not what it guesses you meant.
Okay, but how do we structure this text so a system can actually use it efficiently? Enter the hierarchical script database, also known as HSDB or C-tree-DB. This right here is the engine where our translated text actually lives and breathes. It uses a JSON-like tree structure. Essentially imagine a nested digital filing system to organize all that information. But here's the thing, this isn't just some static Excel sheet. It's a highly active, event-driven database where our instructions are actively executed. And what's truly revolutionary about this is how HSDB completely upends traditional programming logic. Normally in software, your data, which we can call our nouns, is kept totally separate from your executable functions, our verbs, right? But HSDB perfectly unifies them. It co-locates static data properties and active computing logic, slapping them right next to each other to form single seamless notes within the application runtime. It's literally like taking separated nouns and verbs and finally squishing them together to form actual working digital sentences.
Because these nouns and verbs are co-located, these unified nodes can do some incredibly cool things. For one, they create a totally self-explanatory, transparent database. And because it's event-driven, when a new event arrives, let's say a user clicks a button or a new piece of data is ingested, a node can dynamically spawn a brand new child node right there in the tree. The database literally grows organically as new data and events arrive, perfectly structuring our translated human intent as it expands.
But wait, hold on. That brings up a massive, multi-million-dollar problem. If this database acts as a self-reproducing automaton, literally spawning new logical child nodes with every single event, how on earth do we prevent it from just blowing up? Seriously, how do we keep this rapidly growing system from crashing into chaotic overweights and triggering a fatal Stack Overflow?
The architectural answer lies in a kernel function known as SYN. Picture SYN as the super strict, totally uncompromising VIP bouncer standing right at the front door of your digital ledger. This bouncer's one and only job is to evaluate incoming data before a single byte is ever allowed to be written to the database.
And this bouncer operates on a very strict mechanical sequence: thesis, antithesis, and synthesis. Step 1. The thesis. The bouncer checks the JSON state tree to see if the specific database space is empty. Step 2. The synthesis. If it is empty, awesome. It synthesizes the new data directly into that open slot. But step 3 is the kicker, the antithesis. If data already exists in that exact spot, the bouncer firmly and violently rejects the input. Period. No entry.
These strict rules completely eliminate the chaotic mess you typically see in traditional event-driven programming. It completely prevents accidental overwrites and namespace collisions because the data is perfectly parsed and validated against a strict schema before it ever executes. There is zero guesswork here, guys. It is pure deterministic elegance.
In fact, the only way around this bouncer is if a human developer explicitly uses a VIP overwrite flag, like an O flag or an N flag, to manually force an overwrite. This just completely eradicates that messy, probabilistic variance we see so often in AI systems today.
So how does the bouncer do this fast enough to keep up with massive amounts of data? It uses a LIFO architecture, last in, first out. Think back to our club bouncer. A highly efficient bouncer doesn't care about scanning the hundreds of people wrapping around the block, right? They only need to look at the ID of the person standing directly in front of them right now, at index 0, to instantly figure out the absolute state of the line. Because the last item to go in is the first one to come out, the system only ever needs to query the very top of the stack. That establishes a flawless, immediate mathematical proof of the system state.
Okay, so we have this flawless, hyper-fast bridge, but who is actually driving? The documentation frames this dynamic so beautifully. It says, the human pilot applies the intent, but the agent cell executes the sweat. On the left, we have you, the human pilot. You're providing the overarching intent, the rhetorical technique, and the creative strategy via our semiotic bridge. On the right, the AI agent cell acts merely as a deterministic scripter. It handles the tedious computational sweat. This guarantees that as human creators, we never lose control. We hold the reins, and the machine simply executes our mandate.
And this brings our descent to the metal to its absolute climax, because this flawless chain of logic from your messy brain through the semiotic bridge, past the SYN bouncer, and into the HSDB database safely compiles your biological intent into physical execution. It literally reaches out of the screen. This verified on-chain action trickles all the way down to the ultimate leaf nodes of the network. It triggers physical GPIO pins, general-purpose input-output pins, on a physical device. Pure math literally becomes pure electricity. It can spin a motor on a little cheerbot sitting on your desk or, turn on a light in the real world.
Stepping back, this architecture leads to a really striking realization from our sources. Quote, "We are quite literally tricking silicon rocks into thinking using lightning and text. There is no magic here. There's no ghost in the machine. It is just beautifully exact physics, strict deterministic logic gates, and explicit language commanding electrical currents on a silicon substrate to execute our wildest human imaginations."
We've traced this incredible journey from a warm, messy human thought across the rigid textual bridge of the divine script, perfectly sorted by our logical bouncer into unified digital sentences, all the way down to a physical robot waking up in the real world. The semiotic bridge from digital truth to physical reality is officially built, and it's wide open. So the only question left to ask is, as the sovereign steward of the machine, now that you hold the divine script, what will you program it to do? Thank you so much for joining me for this explainer. Keep learning, keep exploring, and I'll catch you next time.